Okay, part 3 of the same example then. Using the same principles, we want the same base number on both sides. So a third we can write as 3 to the power of minus 1. The 27 can be written as 3 cubed. Power raised to another power again, being careful with this negative sign, gives us minus 2x, and minus 1 times the minus 1 giving us a plus 1. We need to be careful there. So we've now got our bases the same. We still, like before, need to equate the powers. So minus 2x plus 1 has to equal to 3. Another very basic equation to solve. 2x must equal minus 2, giving us x equals minus 1 as our answer. Okay, next example then. Part 1, same sort of principle as before. 125 on one side, 625 on the other. Finding our base numbers again to be the same. So 5 cubed from 125, 5 to the power 4 is 625. Power raised to a power gives us 3x. Base numbers the same. Need to equate the powers. 3x equals 4, which must give us then x to be 4 over 3, or 1 1/3 if that's what you prefer. Okay, part 2. Okay, so we've got 27 to the power of x plus 2. We've got 9 to the power of 2x minus 1. So our 27 can be written as 3 cubed. Our 9 can be written as 3 squared, both with the base number of 3. In this case now we've got 2 powers raised to powers, one on either side. So simplifying this first means we multiply the powers here together, giving us 3x plus 6. Same on this side. Multiplying our 2 by the 2x minus 1, giving us 4x minus 2. Base numbers the same. We need to equate the powers. So 3x plus 6 has to equal the 4x minus 2. Take the 3x away, add the 2 on to both sides, and we get x equals 8. Part 3, a little bit trickier because we've got a fraction involved. So we've got a 4, an 8 and a 16. We're going to write them all as base numbers of 2. So 4 being 2 squared, the 16 being 2 to the power of 4, and our 8 being 2 to the power of 3. Power raised to another power again gives us our 6x when they're multiplied together. Power 4 multiplied by the x minus 1 gives us 4x minus 4 as the power in the denominator. Now in this case we need to simplify the left hand side first. So 2 to the power of 6x divided by 2 to the power of 4x minus 4. So we're going to use the division rule, which says we're going to subtract the powers. So 6x minus the 4x minus 4 gives us 2x plus 4, being careful with our signs here, which is still equal to the 2 cubed. Base number is exactly the same. We have to equate the powers. 2x plus 4 then has to equal the 3, simply giving us x equals minus 1/2 as our answer. Okay, moving into the last example then in the indices section. Right, slightly different. Part A then, if x to the power of 2/5 is equal to y, and we're being asked to write x to the power of 4/5 in terms of y, I know that x to the power of 4/5 is the same as x to the power of 2/5 squared if we're working backwards from the power raised to a power rule, which says we multiply them together. And if I'm squaring the x to the power of 2/5, I'm going to square the y. Okay then, so we've got x to the power of 4/5 must equal y squared. So we've written the x to the 4/5 in terms of y. Okay, part B of this example then is going to follow on from part A. We're trying to write this quadratic equation in terms of y and then also use it to find the value of x. So if you remember from part A, x to the power of 2/5 was equal to y, and I then was able to work out that x to the power of 4/5 was equal to y squared. Okay, so that's going to help us now with this quadratic equation, because I've got x to the power of 4/5, which I know is equal to the y squared from part A, so I'm going to rewrite the first part of the quadratic equation as y squared. 13x to the power of 2/5, or minus 13x to the power of 2/5, well, if x to the 2/5 was equal to y, minus 13x to the power of 2/5 we can write as minus 13y. Plus the 36 equals 0, giving us a quadratic equation in terms of y that we can solve. So we're going to factorise it. I have a product of 36. I have a sum of minus 13, giving us y minus 9. Y minus 4 equals 0. If that's the way you solve your quadratic equations, you may also just have done it by inspection. Okay, so y minus 9 is equal to 0, gives us y is 9. Y minus 4 is equal to 0, gives us y equals 4. Okay, so we haven't quite finished yet because we still need to find the value of x. So going back over here again, if I know x to the power of 2/5 is equal to y, well, x to the power of 2/5 then in this case must equal the 9. Okay, so I can say here x to the power of 2/5 is the 5th root of x and then squared. So working backwards from that to solve this equation, I'm going to take the square root of the 9, the opposite of squaring something, and I'm then going to raise it to the power of 5, which is the opposite of taking the 5th root. So the square root of 9, all raised to the power of 5, square root of 9 being 3, and 3 to the power of 5 then giving me 243. Similarly then with our second value of y, okay, so working backwards, we're going to square root the 4, and then we're going to raise it to the power of 5. Okay, so the square root of 4 then is 2, and 2 to the power of 5 gives us 32. We could have also done this the other way around and raised the 4 to the power of 5 first and then taken the square root, but we would still have got the same answer. Okay, always do it whichever way is the easiest with the numbers you've got, considering you don't have a calculator for this module.